What's going on, good people? This video I will be discussing the replacement dining room light fixture that I did in my house. The original light fixture dated probably to the original house. I wasn't able to find like an actual date on it, but it was time for an upgrade. So this is how I upgraded it. All right, so here is the light fixture in my house. The first thing I had to do was to upgrade the switch. I had put a dimmer on this particular light fixture because a lot of times dining rooms do have dimmable lights, but the LED bulbs that I already had on hand do not support the ability to be dimmed. So I had to take that out. Otherwise, you risk destroying the light bulbs in the process. And LED light bulbs have a longevity or expected longevity of about 25 years or so. But if you're trying to dim them and they're not designed to be dimmable, then that life expectancy can be cut short. So, like I say, I removed the dimmer and we'll get back to the dimmer and replacing it with a switch here shortly. And if you're interested on how to replace a wall switch, I do have another video that covers that. I'll be sure to provide a link to that. So if you need to know how to replace a switch, you can do that as well. Just check out that video. This is the light fixture. I got it from a big box store. I will not call the name of said big box store because they do not sponsor the channel. But this is that light fixture that I got there. I managed to get it. I believe it was on sale for about 50 or 60 bucks. And it is I prefer to have the lights pointing down instead of up. I know some people, they have a thing, the lights have to point up, the lights have to point down. I wanted some lights that pointed down. So that's what I got. All right, so this is the original fixture. As you can tell, it looks very dated. I do believe it is original to the house, and the house was built in the late 1970s. So this has been hanging here for over 40 years. So I wanted to go ahead and get rid of it. I did originally think about painting it. You may have seen where people have done essentially they would take it down, sand it, paint it something different color, and then put it back up to better match the environment that they want to have. But I really just didn't like this fixture. In addition, these sleeves here, which are made of plastic, some of them are actually burned at the end where the light bulb was touching the end of the sleeve, and so you have like some burn marks on there as well. And so for me, it just needed to go. Oh, and in addition, so in this portion of the lamp down here at the bottom, there is actually a light socket, but there is no way to screw in a light bulb. And I'm assuming at some point the light got damaged in some shape, form, or fashion. And so you can't even though a bulb is supposed to go there because the plastic housing is there, the metal inside where that bulb would connect to is not there. So it's like, okay, this light works, but it's damaged. So yeah, I came up with another number of reasons to get rid of this light fixture. All right, so the disassembly. So the box plate comes down. There's a twisting nut on there that you just untwist, and then all of this comes down. And this is what I found on the inside. So instead of cutting the wire short enough to be able to accommodate the shortened chain, what they did is they just wrapped the wire around the post. Now, in my opinion, is not the best thing to do. It's best to cut your wire to the length that is needed with maybe a little bit of extra, but this is like the full length of the wire that came with the light fixture. So in my opinion, this was done incorrectly. And one other thing that I noticed as I was about to take this apart, so if you see here, there is a ground wire that comes up from the fixture. As you know, this fixture is made out of metal, and the reason why you have that ground wire there is if something goes wrong within the fixture and a wire comes loose, that ground wire is to provide a route for the electricity to go back into the circuit instead of into somebody that may accidentally touch it. And What happens a lot of times, you have these light fixtures over the table. If they're low enough, people like myself, that have, at least 6 feet or so, can have a tendency to bump their heads on the light fixture. And the last thing you want to do is get up, bump your head on the light fixture, and get electrocuted. So I kind of fault whoever wired this up originally for not connecting that ground wire. When you, if there's the rule that I've learned is that if there is a wire on a fixture or on a switch or whatever the case may be, then it needs to be utilized for its designated purpose. And the ground wire in this case was not utilized for its designated purpose. I am in a handyman group on Facebook, and so I made this comment about how this ground wire was not connected. And so one other handyman who is also in it's close to the area that I'm in, mentioned that it seems to be a common theme with the light fixtures in his experience that they were not wired with the ground wires connected, which in my opinion is a major hazard. But outside of that, everything else in this light fixture, as far as the wiring connections go, was done correctly. You're probably asking, well, if the ground wire was not connected, where would it go? Or if it was connected, where would it go? So you can either mount the ground wire. Well, you'd also need to really need to mount it to the ground connection that's in the box. And there is a ground connection in the box. But you could also have to ground this mounting bracket as well. Usually you see the wire from the fixture itself grounded, as well as the mounting bracket also grounded, because you can have static electricity build up in the light fixture. It's not something that you think about, but it is something that does happen. You may have touched a light fixture and gotten zapped, and that zapping is the static electricity that has built up in the air and thus onto the fixture, and then you touch it and get zapped in the process. So that's another reason for making sure that your fixtures are grounded. All right, so I started taking things out of the box, and here we have the new mounting bracket. We have the cover plate, we have the chain, and we have some other mounting hardware. This came with wire connectors. I did not use the new wire connectors because the existing wire connectors were still functional. All right, and so I got the mounting bracket in, as well as the uh, chain and light fixture connected to it. This particular this particular ceiling fan, excuse me, this particular chandelier has one of those hooks similar to the keychain type hooks, where you just slide it over and it breaks away and then comes over and then locks back in place afterwards. It has one of these at the top and bottom so at the top where it connects to the mounting bracket, and then at the bottom where it actually connects to the fixture itself. All right, so the next part is to connect the new switch. I do have aluminum wiring in my house, and this particular switch was designed to only be used with copper wiring. So what I had to do was to use the aluminum connectors. I know some people frown at the fact of using aluminum connectors, but given that this is not pulling a lot of current, and I don't see it having any issues. If you are using something that does pull a lot of current, like a high powered light or something of that nature, then you'll probably want to not use this type of aluminum connectors. They have the other type where you stick the wire in and you screw it down instead of you just twisting them together like typical wire nuts. That would probably be more suited for those applications that are pulling a lot more current than like this light fixture here. But the reason why you have to use these aluminum connectors when you're connecting aluminum to copper, and the reason being is because aluminum and copper have different rates of expansion because they are two different metals. I'm not going to get into the science of that. That is where the periodic table of elements come in and a whole lot more. But basically, the two metals expand at different rates, and so what happens is because the wires move at different rates, they can expand like this and cause an arc. And so what these aluminum connectors do is there is a gel in there that is designed to prevent arcing from taking place. And that's how you prevent the fire, from the wiring causing a fire. I have noticed some of the connections on my house do not have these, but should have these. So as I do changes to them, I do make sure that I pay attention to that and go from there. So that's why you see these purple wire connectors on here. My house is designed with a what is known to as switch leg design, and so that's why you see this neutral, what appears to be a neutral, but is actually not a neutral, is actually a hot wire that returns on the neutral that is connected here. So this actually comes down from the light switch box and to the switch, and then goes back up to the light switch box on the black wire, and then the black wire connects to the light fixture in the ceiling. And this switch has a ground on it, so I had to connect the ground as well. Some of the other switches in the house do not have grounds. They just have the 2 terminals and that's it. So like I mentioned before, if it has a wire or a connection point on it, you need to use it. Otherwise, they wouldn't put it there and not for you. They wouldn't put it on there for you to not use. So again, wire it in if there's a connection point for it. All right, and so it took me a moment, but I had to make adjustments to the connection point up here to get this panel, this light housing cover on correctly, because of the fact it would not go on because I think in part because the light switch box, excuse me, not the light switch box, the junction box in the ceiling was not secured as well as it probably could be. Like as I was working on it, it was actually trying to move back up into the ceiling instead of staying flush with the drywall. Also, when you're doing this setup, the chain is not, the electrical wiring is not ran through the chain. So what most people do is they run the wire in between the links of the chain. And what I did here, I ran the wires in between every other chain link, and that's how you get this pattern here. That way you don't have the chain and then you have 2 separate wires running next to the chain. You just intertwine it. And I also did cut this chain to the appropriate length so that it does not have to be wound around like the previous light fixture that was installed was done. And so this is it without the light bulbs and the shields on it. It's a 5 light fixture. It has I believe a maximum rating of 60 watts total. So 60 divided by 5, what's that, like 12, 13 watts a piece, I think it is, somewhere the math comes out to per light bulb. And you can only use CFLs or LED lights with this fixture. And it specifically says that in the instructions. All right, and then this is the light once the bulbs and the shields are put into place. I will say, and it probably is in part because of the light bulbs that I'm using, this light fixture is way more brighter than the previous light fixture was, and the previous light fixture had 6 bulbs on it, all of which were of higher wattage. So like I said, I think that had in part to do with the bulbs, but nonetheless, this does work. And so, and then here is the fixture, but turned off. So you can see what it looks like without the bulbs on. So that wraps things up for this video. Any questions, comments, please drop those in the comment section below. Also, be sure to subscribe to the channel. I do new videos every week on Tuesdays and Saturdays. So come back and come back often. Also, please be sure to give this video a thumbs up. It is much appreciated that the people that watch these videos are showing their appreciation by giving a thumbs up. That lets me know that you're actually interested in this content. Until next time, peace out.